Greetings, welcome back. The 3n+1 problem says start with n. If n is even, cut it in half. If n is odd, multiply by 3, add 1, and cut that in half. Then repeat. The conjecture says no matter what number we start with, we'll eventually wind up at 1. And when we do, we'll enter a tiny little loop, because after we reach 1, well, 1's odd, so 3 times 1 plus 1 is 4, divided by 2 is 2. 2 is even, so then we cut it in half to get 1. So that's our tiny little loop. By now we take it for granted that there's a loop involving 1, and the 3n+1 conjecture says that's the only loop there is. Let's look at 5n+1. If we start with 1, we get 5 times 1 plus 1 equals 6, divided by 2 equals 3. Then 5 times 3 plus 1 divided by 2 is 8, then 4, 2, 1. So another loop involving 1. And 7n+1. Starting with 1, we get 7 times 1 plus 1 is 8, and we know that'll crash back down to 1. At this point, we might conjecture that all qn+1 problems have a loop involving 1. So let's try 9n+1. Let's see, 1, 5, 46 divided by 2 is 23, 104, 52, 26, 13, coming back down. But then 59, 266, and pretty soon we're off into the millions and billions. And it looks to be diverging off to infinity. I mean, it might eventually accidentally hit some power of 2, why not? Come crashing back, but looks doubtful. Anyway, 9n+1 doesn't have a tight little loop like 3, 5, and 7. And same thing for 11n+1 and 13n+1. Starting with 1, things seem to run off to infinity. But look here, 15n+1 has another tight little loop involving 1. Okay, so we got some data now, and there's a pretty simple explanation. If we plug 1 into 3n+1, we get 4, which is a power of 2. If we plug 1 into 7n+1, we get 8, same thing. And 1 into 15n+1, we get 16, which is a power of 2. And so you can bet a 31n+1 problem also has a little loop involving 1. But that doesn't explain the 5n+1 loop. So we might expect 1 to escape off to infinity like most numbers do under 5n+1. But after 2 steps, 1 happens to luckily land on 8, so it gets back home. No escape for number 1. Which leads to another question. Are there other qn+1 problems that work like that? That is, where we hit a power of 2 after 2 steps. So I tried hundreds of larger qn+1s, and sure enough, it happened just one more time with 90n+1. Starting with 1, we get 90 plus 1 divided by 2, or 91 halves. Is that even or odd? I don't know. Let's call it odd. So we multiply by 90 again and get 4095, add 1, divide by 2, and the result happens to be 2048, which goes to 1024, 512, 256, and so on, down to 1. So that's a loop of length 13 involving the number 1. And it's a pretty weird loop because it's got a fraction right in the middle of it. But aside from that, 5 and 90 seem to be the only numbers that have this kind of loop. Start with 1, go up twice, then go straight down and return to 1. So I don't take the 1-to-1 loop for granted anymore. Just so happens that the 3n+1 problem has a loop at 1, but other problems don't. One more thing. Let's take a look at the 3n+99 problem instead of the 3n+1 problem. Well, instead of making a loop that starts with 1, we can easily make a different loop that starts with 99, because 3n+99 is just 4 times 99, which cuts in half to 2 times 99, which also cuts in half, and we're back to 99. Okay, so our knowledge about 3n+1 is growing, so let's keep going.